Houston, how rapid urbanization led to mass flooding. Hello everybody, I'm Stifter and I'm with the University of St. Thomas Geography and Environmental Studies Department. Today, I'm going to be showing you a little bit on Hurricane Harvey and the flooding that happened just 2 months ago in Houston, Texas. An article in the Washington Post from September 14th, roughly 2 weeks after Hurricane Harvey made landfall, sets the death toll at 82. And Texas officials have been quoted as saying mass casualties have absolutely not happened. These same officials also say that it could take weeks to accurately get a casualty count, and the casualty count could have been much higher. Unfortunately, due to the flooding, some hospitals had to be evacuated, and in general, emergency responders along the coast were overwhelmed. At the height of the flooding, more than 30,000 residents were living in various shelters across Houston and elsewhere. Roughly 21,000 households were living in 2,000 different hotels in 33 states. One of the first tasks for rebuilding Houston is clearing 200 million cubic yards of debris. Still, there are 3,900 homes without power, and 77 water boil notices are in effect. So now that we looked at some of the effects of Hurricane Harvey, we can look at it by the numbers. In some areas, Hurricane Harvey dropped more than 51 inches of rain, setting a new continental record in the U.S. Hurricane Harvey was trapped between two high-pressure systems to the north and to the south, keeping it locked with 1 foot over the coast and 1 foot on land, acting like a conveyor belt pulling water out of the ocean and dropping it onto the land. All in all, there were 500,000 to 1 million vehicles damaged or destroyed, and some families may have to wait 2.5 years before they are in permanent housing again. Unfortunately, aid funding won't be available until next year at the soonest. For a period of time from the 1990s to the early 2000s, Houston was the fastest growing city in the United States. 1990 to 2000 alone saw a 20% increase in Houston's population. To house that growing population, land was developed and urbanized around the city, causing a loss of open space and land use that, on a large scale, altered ecological processes. In the ProPublica article Boomtown, Floodtown, we find that Houston experienced major population growth not only from 1990 to 2000, but that trend also continued all the way to 2010. During this time, urban area increased more than 52%. On the right, we have a graphic showing the various progression of urbanization from Houston. In the light pink here, Houston 1990 and onward, we can see a major expansion within the city limits. Houston, to keep up with the massive population influx and the need for housing, relaxed building and zoning regulations. Unfortunately, one result of this was the building of houses within FEMA floodplains. I highlighted some areas here in red on the maps, showing especially high concentrations of houses within floodplains. Now, if building in floodplains wasn't bad enough, the soil around Houston is absolutely terrible as far as floodwater drainage goes. The soil is mostly made of clays and sand. This means that water runs off and doesn't soak in. Most of Houston is also very flat and very low in elevation, promoting poor drainage. 25% of Harris County alone is within a floodplain. Another cost of this rapid urbanization was the loss of prairie, wetlands, and forests, all areas that could absorb this water and slowly release it over time. Instead, it was replaced by impermeable surfaces such as tar and concrete, surfaces that do not allow water to penetrate, and as such, all the water that is collected on these surfaces just runs right into the drainage systems. One issue that was experienced in Hurricane Harvey was either these drainage systems could not keep up with the flow and backed up, or these drainage systems faced blockages from various debris, also causing backups and more serious flooding. Now, of course, one of the big questions on everybody's mind is how many billions of dollars will it cost to rebuild after Hurricane Harvey? An NBC article states that the cost to rebuild is still unknown, but estimates at the current time range from $48 billion to $75 billion. The analysts stated it was very complicated to predict costs, and the overall Hurricane Harvey is expected to have a $190 billion effect on the economy. It could take weeks or even months to recover from this historic storm. As I started analyzing drainage systems and their capacity to divert floodwaters, I came across this article, Pluvial Flooding in Urban Areas, the Invisible Hazard. It's coined the invisible hazard, pluvial flooding, because of its quick occurrence, and it usually happens without warning. It typically occurs when drainage systems fail to handle large amounts of rainfall. This can be anywhere from short duration storms, dropping about 1 inch per hour, or about a ½ inch per hour over longer periods of time, especially if the ground surface is impermeable, such as tar or concrete, as we saw in Houston, or in many other urbanized areas. Another man-made issue that could have contributed to Houston's terrible flooding is called coastal subsidence. In the Houston-Galveston area of Texas, ground level is decreasing roughly 1 inch per year. It's mostly due to the massive water demands, and the city trying to fulfill that pumps water from the aquifers. As the water is drained, the ground compresses and shrinks. There is also a small oil gas extraction component, but this is effectively causing sea level rise because as the land shrinks, the sea moves in, and you experience the same effects you would as sea level rise. Now, the research topic I decided to really dive into was what amount of land has been converted from rain-absorbing natural areas to urbanized areas, and where have these conversions largely taken place. Now, utilizing ArcGIS and data from the National Land Cover Database, I was able to establish which areas in 1992 were these natural areas such as forests, prairies, or wetlands, all water-absorbing areas, and compare that to the same areas in 2011. Highlighted in blue are areas that were natural at one time in 1992, but by 2011 were converted to urbanized areas, be it housing developments, roads, or other kinds of modern-day, non-natural, man-made structures. Again, utilizing ArcGIS, I clipped the Houston metro area, I zoomed in around the city itself, and I overlaid areas that were flooded with these areas that were converted. Circled in red are areas that were urbanized, that did experience land cover change from natural to urbanized, and experienced a substantial proportion of flooding. After identifying the problem, I decided to look at some solutions. These solutions include permeable pavement, more green space, and upgrading the stormwater systems. Now, with permeable pavement, water will be able to move through instead of over the pavement. This is done by creating porous spaces within the concrete by using larger aggregate or larger rocks, larger stones when they make the concrete. More green space. What could be done is protect these wetlands, forests, and natural areas that still remain, and because of that, water will be captured by soil instead of running off right away. This puts less of a strain on the stormwater systems and on the area in general. Another potential solution is upgrading and retrofitting the stormwater systems, because as currently, these systems are insufficient to handle demands. Unfortunately, this is very expensive and would cause major traffic delays. As you can see pictured on the right, as the hose sprays down on this concrete, water is still able to move through it relatively easily. As I said earlier, this is due to the larger aggregates creating voids between that water is able to move through. It's a drainage system unto itself, which reduces floods and recharges groundwater. Many homes already utilize permeable pavement for driveways. It's a cost-effective replacement for traditional drainage. More green space is also never a bad option. This increases soil volume and soil exposed, which allows water to seep in and be held. As such, plant roots hold the soil together, reducing erosion. The roots also hold water and allows the water to disperse at a slower, more manageable rate. Protecting wetlands is also very important, as found in this article by Fast Company. Wetlands and coastal ecosystems do protect coastal areas by lessening erosion, allowing the water to soak in and drain out over time. Best of all, they are natural, and there is no extra cost to build. It is estimated that during Hurricane Sandy, coastal wetlands saved an estimated $625 million worth of property. As a way to even further increase green space and soil, The Houston Corridor Guide to Sustainable Development from 1999 suggests rooftop gardens and backyard plots. Through the course of my research, I have come to several very important conclusions. One, the extent of flooding Houston experienced could not have been prepared for. 51 inches in a short span of time, a new record level in the continental U.S., you can't prepare for that. But one thing they could do is retrofit or install new drainage systems. Already the drainage systems are only rated to handle a 1 in every 10 years rainfall. Another thing that could be done is update the flood maps. Usually such task is undertaken by FEMA, but FEMA is experiencing funding issues, so that could be taken up by university students from either one of the local Texas A&M universities or one of the other universities that work with GIS. I'm sure the internship experience would be most welcome. We can also use this as an experience to learn from. We can see what mass urbanization does, and we can also learn how to deal with flooding issues. All in all, Houston was a tragedy, but we should try to make the best of it. Thank you for listening. Have a pleasant day.